Hey guys, welcome back to Jyoti classes, and today we are going to start with the matrix part. See, we have came so far in the mathematical physics covering all the things, and this matrix part is the last part of MMP. So we have covered everything that will the possibility to be asked in mathematical physics, that is, we completed complex functions, we completed Laplace transformation, Fourier transformation, differential equations, difference like now we are going with matrix. Okay, these all things are covered in the videos, and almost I have given you the clear notes of these concepts and the important formulas that you should know before learning the concepts, or before solving the any questions, because without knowing what is there in a given subject and what are the important formulas that you should be aware of, you'll be not able to solve just seeing by question. So for that purpose I have given you the neat notes of all formulas in mathematical physics, including everything whichever I felt important and which is repeatedly asked. I have mentioned those. So if you are maintaining the proper notes, then your mathematical physics notes are done, and that with the time of revision it will be going to help you a lot. Okay, so let's learn the last part of mathematical physics, that is our matrix. Okay, in matrix also I have just mentioned simple things which you should be aware of, and so that while seeing the questions you can solve it out. Okay, so the first thing is from basic I am starting. The first thing is what is square matrix, where number of rows is equal to number of columns, and for which we will say a diagonal matrix when the principal diagonal elements are not equal to 0. This is our principal diagonal elements. And what is the scalar matrix? If it is a scalar matrix, then the principal diagonal elements are same. What is an identity matrix or a unit matrix? In an identity matrix or a square matrix, where the diagonal elements are 1. Okay, and what is a row matrix? If you represent in this form, this is a row matrix. And if you represent, what is column matrix? If you represent in this form, this is our column matrix. This is few things which will be already knowing, but still I have make a note. Next, which one is an upper triangular matrix? If any given matrix form is in this form, where the base these are 0, then this is upper triangular matrix. If these are 0, then it is the lower triangular matrix. Okay, now for a periodic matrix, a to the power of n plus 1 is equal to a. Okay, where a is the period of the given any matrix. These are the simple things which you will be already aware. I am just making a glance on all those things, for which we will call as important matrix, that is a square is equal to a, where the period is 1. And the next thing for which we will call as a singular matrix, where determinant is equal to 0, then it is a singular matrix. If non-singular matrix, for determinant not equal to 0. Nilpotent matrix, where a to the power of n is equal to 0, and here where the trace is also 0 and the determinant is also 0. First of all, what is trace? Trace is nothing but sum of the principal diagonal elements. Okay, next, coming back to involuntary matrix or the self-inventory matrix, where a square is equal to identity matrix I, where a is equal to a inverse. Okay, this is our involuntary matrix. Next, coming back, trace of a plus b is individual trace of matrix A and individual trace of matrix B. Similarly, with the constant a trace is there, you have to get the value as c into trace of a. Trace of a into b is equal to trace of b into a. This is something like commutative law, that AB is equal to BA condition. If the trace of AB is equal to, then the trace of BA. Okay, this is the condition. Next, transpose of any given matrix is nothing but changing the rows into column. This is our transpose matrix. And if you have to take the transpose conjugate of the given matrix, just transpose it and take the conjugate of that given matrix. Okay. And some of the identities I have mentioned here, that is A transpose, the whole transpose is nothing but A. AB whole transpose is nothing but B transpose into A transpose. Next, the symmetric matrix, that is A to A transpose is equal to A if Aij is equal to Aji. This is our symmetric matrix. To find the number of independent component in the symmetric matrix, see, this is important. They have asked question based on find the independent component for the symmetric and the non-symmetric matrix. So for you it is important to know to find the independent component. 1 by 2 is equal to 1 n into n plus 1, where n is the order of the matrix. Okay, this is important. Remember this. Next, for a symmetric, or I can say skew symmetric function, that is A transpose is equal to minus of A. The number of independent component is 1 by 2 by n into n minus of 1. One more thing you have to remember, that for the principal diagonal element for a symmetric or a skew symmetric matrix is 0. This is directly they have asked at one of the year question paper. While solving question paper, you will come across this. Next, coming back to now, if every square matrix can be written in the form of sum of square matrix and the skew symmetric matrix. Okay, this is the form of representation of any square matrix. Okay. Next, Hermitian matrix, if A transpose is equal to A, here principal diagonal elements are always real. And for n cross n matrix, the minimum number of real elements will be n. Okay. Next, for skew Hermitian matrix, A transpose is equal to A. Here the principal diagonal elements are either 0 or imaginary. You will never know that whether it is Hermitian matrix or skew Hermitian matrix, or whether it is symmetric matrix or asymmetric matrix, because just see, A transpose is equal to A is similar to Hermitian matrix also, and for skew symmetric or asymmetric matrix, A transpose is equal to minus of A, and that is also for Hermitian matrix also. How can you differentiate whether which type of matrix it is? Just focus on the principal diagonal elements. If you focus on principal diagonal element, you will be directly getting to know whether it is Hermitian or non-Hermitian matrix. For Hermitian matrix, it is always real. For skew Hermitian matrix, it is either 0 or purely imaginary, and here the number of minimum real elements is 0. If you remember this clearly, you can solve any questions. If directly if they are asking, it is going to help you out. Okay. Next, to know the inverse of any given matrix, find A inverse is equal to adjoint of A by determinant of A. Here I have written what is adjoint of A, and for your reference I have written this. You all will be aware of this, how to find that. Next, moving on to the orthogonal matrix. Okay, for the matrix which is not non-invertible, then the determinant is 0. For orthogonal matrix, A into A transpose or A transpose into A, that is equal to identity matrix, and its determinant will be either 1 or minus 1. Okay. Let these many formulas for today's class. So make a note of all these simple formulas which you should remember to solve a complicated questions. So this much for today's class. Thank you guys.